All right, I wanted to continue here talking about the central limit theorem, and I realized I needed to make a small correction here to my notes, so I'm going to add that here. This, the standard error of the mean, this should really be a mu sub x right here, and basically that's the standard deviation of our samples over the square root of n, and that still follows out to be the standard deviation of the samples. It doesn't really change the work for this or how it all goes, but I just wanted to make sure I had that correct. So now, jumping in for another example, and this is again the central limit theorem as it pertains to means. A manufacturer knows that their items have a normally distributed lifespan with a mean of 15 years and a standard deviation of 3.1 years. If 22 items are picked at random, 9% of the time, their mean life will be less than how many years? Give your answer to one decimal place. So I'm going to steal this here, and then I'll go over to Excel and show you how I would work the solution and how I recommend that you do too. Anyway, so new sheet, continuing from the old here. A manufacturer knows their items have been normally distributed with the lifespan, have a normally distributed lifespan with a mean of 15 years and a standard deviation of 3.1 years. If 22 items are picked at random. So this is how we know there's a little change here from what we've done previously. Now we're talking about 22 items. 9% of their time, their mean life will be less than how many years? So I'm going to draw a picture here and see what we have. If 22 items are picked at random, 9% of the time, their mean life will be less than how many years? So got my normal distribution. Now what I have here somewhere in the middle is 15. And then 9% of their time, their mean life will be less than how many years? So somewhere over here, we're looking for a value. And this area would be 9%. And so I'm looking for a cutoff here. Now, since I know I'm talking about means, I've got to figure out what the standard error of the mean is. And this is one of the formulas that is on your sheet. And it's going to be sigma over the square root of n. Now, you can kind of put this into your function and let it ride, or you can solve it here. I like to do it here and then just let the work happen. So our standard error gets shrunk way down. Our old standard deviation was 3.1, and now we're talking about 0.66. So this is going to be probably pretty close here to this one. Now, since I'm looking for an output, and I'm looking for an output here, and this is the nice thing about drawing a picture, I'm trying to find a value. So I'm looking for an x, an output. And so I'm going to use the normal inverse here. And I know my probability, the low side 0.09, the mean 15, and then the standard deviation, it switched to the standard error. And notice how much closer we are to 15 than if we had a standard deviation of 3.1. And so give your answer to one decimal place. This will be 14.1 as a final answer here. And again, just a little change of pace. We're talking about a sample of items, and so we know we have some change happening here. Now, particular fruits weights are normally distributed with a mean of 613 grams and a standard deviation of 17 grams. If you pick 19 fruits at random, what is the probability that their mean weight will be between 607 grams and 617 grams? So go ahead, snag this one here. And hop over here to get to work. So a particular fruit's weights are normally distributed with a mean 613 and a standard deviation of 17. If you pick 19 fruits at random, what is the probability? So now we got 607 grams is less than x bar less than 617, there. So we've got an in-between thing here, and since I've talked about the pictures and the importance of the pictures, I'm going to draw myself a picture. So here we have a distribution, and when I have this thing adjusted here, I'm not super worried about what the picture is going to look like. I could find the standard error of the mean and try to group it a little bit closer, but also I could just kind of go, okay, I'm going to have 617 on this side and 607 on this side, and I'm looking for this in between. Now it could be that that's grouped a lot closer, and if I wanted to find that out, I guess I could figure out the standard error here, but the picture is just a generalization also, so I'm going to have 17 divided by the square root of n for this one. So now we're talking about almost 4 or so. And so 613 minus 4, this would be 1.5 standard deviations on this side and 1 or so that way, just roughly. So the probability then becomes, and I'm going to just write it down here, I'll do a normal distribution, and I got to take my high side, so this is the 617 with the mean and the standard error of the mean and true, and then minus here another normal distribution, and I take the low side value, so again this one we're between 607 now, and I've got the mean and the standard error of the mean and true. Anyway, so I'm getting a value here, putting it all in Excel and letting it do the work. I'm going to round this 78549, so it's going to be 7855 as my rounded value there. Let's see. I thought 9% of the time. Did I do this one? What were my questions here? Sorry. Went through some. Okay. Well, I got a little bit of time, so I think I'm going to tackle this one. This one's new. A particular fruit's weights are normally distributed with a mean of 639 grams and a standard deviation of 22 grams. If you pick 10 fruits at random, then 17% of the time their mean weight will be greater than how many grams? So again, a little snip. Steal this stuff. Head over to Excel to do some work. Particular fruits' weights are normally distributed with a mean of 639, a standard deviation of 22. Talking about a sample of 10. So we get a new standard error here, which is going to be, go ahead and type it out here, 22 over the square root of 10. Maybe close this time. So if I do that, maybe it's helpful here in getting a little bit of a better picture. So drawing now. Whoops. Not sure what we have happening here. Okay. So normal distribution. I've got 639 in the middle. Now, 17% of their time, their mean weight will be greater than how many grams? So 17% of the time it's greater. So this over here, 0.17. And we're looking here for a value now along there. Remember, if this is 0.17, then this is 1 minus that over here. And Excel needs the area to the left. That's supposed to be a 3. Anyway. So I'm looking for the cutoff value here. So it will be a normal a normal inverse. I got 0.83. I've got the mean and the standard error. And close it up. Nearest gram, 645.6, 646 grams. Thanks for watching. I hope that's helpful.